Hello my dear students, welcome in maths class, and in this class I am going to discuss chapter number 7, coordinate geometry. So I am going to start very first topic, distance formula. So let us suppose a coordinate axis, it is a Cartesian plane, and Cartesian plane is a plane where both x-axis and y-axis they are perpendicularly meet each other, and this point is called the origin. Let us take 2 points in this Cartesian plane, A and B. The coordinates of the first point A are x1, y1, and coordinates of the second point B are x2, y2. And we have to find the distance between these 2 points. So what is the formula? That is called distance formula, and how this formula is derived. So let us discuss how this formula is derived here. So A coordinates are x1, y1. So when we'll write x1, y1, x1 is the distance from the y-axis and y1 is the distance from the x-axis. Let us suppose I am writing the points 2, 3 here. Suppose 2, 3 are the coordinates of the point A. So 2 is the distance from the y-axis, because when we'll plot this point on the Cartesian plane, so we will see here the value of x is 2 in front of x. So this 2 is the distance from the y-axis. So this point is 2, 3. So it means 2 is the distance from the y-axis and 3 is the distance from the x-axis. In simply, if I will say x1 is the distance from the y-axis and y1 is the distance from the x-axis. In the same way, here x2 is the distance from the y-axis and y2 is the distance from the x-axis. So what we'll do here, let us draw perpendicular lines on the x-axis. Let us say its name is R and this point name is S. And draw a line parallel to the x-axis from this point A. Let us suppose that this point is P. So these lines are perpendicular and is AP is parallel to this x-axis, so this angle is a 90 degree. So here APB is a right angle triangle formed. Now if we have to find the distance AP, so AP is equal to the RS, and if we have to find the distance RS, this distance RS is equal to OS minus of OR, and OS is x2, because x2 is the distance from the y-axis, it is x2, and OR it is x1. So here RS is equal to x2 minus x1, and RS and AP both are equal. So AP distance is here x2 minus x1. So AP is equal to RS, this is x2 minus x1. In the same way, if we have to find the distance is BP, so BP is equal to y2 minus y1. This is y2 minus y1. So now in this triangle APB, we will apply the Pythagoras theorem here. So in triangle APB by Pythagoras theorem, hypotenuse square, this is equal to base square plus perpendicular square. So opposite to the 90 degree angle, hypotenuse is AB here. So AB square, that is equal to base, and base is here AP, and perpendicular is a BP. So AP is here x2 minus x1, and BP is y2 minus y1. And this is left side is AB square, but we have to find only AB. So by taking square root on both sides, x2 minus x1 whole square plus y2 minus y1 whole square. Now this side, the square and square root will cancel out. So what is the answer here? AB, that is the distance between these 2 points A and B. A is the starting point and B is the final point or ending point. That is equal to x2 minus x1 whole square plus y2 minus y1 whole square. This is the distance formula between the 2 points on the Cartesian plane when coordinates of A and V are given to you. So we have to find the distance, so we will use this formula. Let us suppose that the coordinates of point A are 3, 2 and coordinates of the point B are 4, 5, and we have to find the distance. So I am writing here AB. It means the distance between these 2 points, A is the starting point and B is the ending point, that is equal to x2 minus x1 whole square plus y2 minus y1 whole square. So initial point is A, so these coordinates are x1, y1, and the final coordinate is B here, so that is x2, y2. Now substitute the values here. 4 minus 3 whole square plus 5 minus 2 whole square. So 4 minus 3 is 1 square, and 5 minus 3 it is coming 3 square. So 1 square is 1 and 3 square it is coming 9. So 9 plus 1 is coming 10. So answer is coming under root 10 square root 10 units. This will be the answer. In this way we will find the distances between the 2 points, and where we will use this formula. Suppose in a triangle we have to find out it is isosceles or equilateral triangle. So we will find all the distances, and after that if 2 sides will be equal, then we will say that it is isosceles triangle. If 3 sides of the triangle are equal, then we will say that it is equilateral triangle. In the same way we can apply this formula in quadrilaterals. We have to check it is a square, it is a rectangle, given coordinate is a rectangle, which type of quadrilateral is this. Then we will find all the distances, and after that we will find out it is a square or rectangle, which type of quadrilateral is this. So one more thing is here, if we have to find the distance from the origin, that is a special case of this distance formula. Let us suppose that this point P is given to you. Coordinates are x, y, and it is the origin here. We know that coordinates of the origin are 0, 0, and we have to find the distance of this point from this origin, that is called OP. So let us suppose that it is x1, y1 and it is x2, y2. We know that the distance formula is x2 minus x1 whole square plus y2 minus y1 whole square. So here x2 is x and x1 is 0, so x minus 0 whole square plus y2 is here y and y1 is 0, y minus 0 whole square. So x minus 0 whole square, it becomes x square and it is coming y square. So this is the distance of a particular point from the origin, that we can say here OP or distance. So this is on another case when we have to find the distance of a particular point from the origin. So we can use this direct formula, x square plus y square. So thank you in this video. Thank you very much.